But if we can take this water waste mixture, this sludge, and re-mineralize it and return that back to the system, we've now created an almost zero discharge system that needs very little replacement of water every day. Hi everybody, this is Charlie Schultz. I'm streaming here from Santa Fe, and I'm going to show you a new system that's up today. But I want to talk about my passion in aquaponics and what really got me involved. And I would say since the beginning of my career, I've been involved in waste treatment. And that's really the idea of a raw system where we can concentrate our waste and we can use it in various ways. So I'm at a facility here in Santa Fe right now that's being built, and it's a very unique design. I like to say that if I walk into an aquaponics facility or try to manage somebody's aquaponics system, that I can manage anybody's system if I know the flow, if I understand the layout. So we always encourage people to follow the plumbing and understand the loops that are present. And the facility we're in today is a very unique facility. I'm going to talk about their waste management. So aquaponics, as we know, the plants are using the dissolved waste, and the plants are the filter, allowing us to recycle the water. But what about all that discharged solid waste? Since I've been working at UVI, we've always had to manage solid waste. We often talk about many failures in this industry are the businesses who didn't manage solids waste properly. So with solid waste, we have to think about settleable solids, we have to think about fine suspended solids. And if we don't, they're going to break down and produce more ammonia in your system and can contribute to heterotrophic bacteria and anaerobic zones. So we have to do this properly. After the fish tanks, generally we have some type of solids removal device where we have either passive or mechanical devices that are removing the large settleable solids first. If we can take care of that portion first, then we can start to manage the fine suspended solids or particulates. And if you don't manage those will all end up in the bottom of your troughs if you're doing DWC. Even the fine particulate solids that are suspended in the water column, over time will start to flocculate together and settle out. So we need to be very diligent in this area. This system that I'm touring today has a very unique way that they're dealing with their waste. On the front end, after the fish, they have a radial flow settler that's going to take out the bulk of the settlable solids, but we're still going to have quite a bit of solids pass through that system. So in this case, we have a bead filter, and this bead filter has a very specific bead media that we're using here, activated filter media, and it's a glass bead. And the glass bead has been designed, this AFM media, to really prevent a lot of heterotrophic bacteria and solids accumulation. And when we backflow and backwash this filter here, we get another slug of solids removed after the radial flow settler. So this is a secondary filter. This is the second filter in the loop to remove solid waste. And before we go to the biofilter, we want to make sure that it's clean and purified. So in this system, I can see that we have a UV filter, but it's moving on to the biological filter. And that's just an MBBR with your coldness media, or your K2 media, where your bacteria live, your nitrifying bacteria live. And we discussed today these need a lot of oxygen, so we want to make sure this facility has good aeration in these systems. So then what do you do with this waste, right? I learned when I started my career, this isn't waste, and this is why I got into aquaponics. In many areas, we can just put this and land apply it. We can put it on our orchards and in your compost piles and in your gardens. It's a slow release fertilizer, and it adds organic matter. So again, it's not a waste, it's a resource. Most indoor facilities like this are, we're gonna be remineralizing this waste. We're gonna be putting this into an aerated vessel, and we're gonna allow that aerobic process and the microbes to break down the bound up nutrients that are in the solid waste. Again, often this is discharged, and we pay to get rid of this. So instead, we're going to capture those nutrients, we're going to remineralize them, and we're going to add all those nutrients, in many cases, back to this same closed-loop aquaponics system. Typically, if you're discharging your solid waste, like through a backwash process, we may replace 1% to 2% of the water volume here every day. But if we can take this water waste mixture, this sludge, and re-mineralize it and return that back to the system, we've now created an almost zero discharge system that needs very little replacement of water every day. Nick Savidov is my colleague and one of my good friends, and he's leading the world in this area. Remember, there is no waste, and what we're showing, it doesn't have to be fish waste. We can do this with all livestock waste. So we'd like to see more of that in our industry, closing that loop even tighter, and waste processing and waste recycling is a great field for anybody here to specialize in and add aquaponics into that. So it really can launch you into your career, and it's the future for our planet is reusing this waste.